Hello, welcome to today's webinar. We'll get started in a minute or so. Just let people pop in. Okay. Some people popping in. This is my first time leading the webinar. I'm Jessica Finnegan. Many of you might have emailed me or had interactions with me. I'm the customer success manager here at Coreform. So if you ever have problems, always feel free to contact me. In today's webinar, will be presented by Karl Merkley. We are going to cover the new features in our most recent release that we just released in April. And Karl will walk us through the main improvements that we've made that might be of interest to everyone. And yeah, and so if you're new to Coreform Cubit, Cubit has features to import CAD models and to clean them up for meshing. It has semi-automated hex meshing that allows control of mesh properties and excels in scripting capabilities. If you have any questions throughout this webinar, please put them in the question and answer portion of Zoom, and we will cover those either in a particular section that you're interested in or at the end. This webinar will be recorded and will be put on YouTube, and we will send out a recording to all registered participants. With that, I'll turn the time over to Karl.
Okay, let's talk about, we're going to just jump right in and talk about some of the changes and really some of the things that I think are kind of important in this new release. Many of our customers use Python to do scripting, and many of those scripts are actually run externally, such that you run Python and you bring in a script and run Cubit. Now, previously, there was a constraint where you had to use the exact same version of Python as the version that Cubit was built with. This constraint has now been removed, and Coreform Cubit is now compatible with Python versions 3.7 and up. So it has to be a relatively modern version of Python, but it will work with everything. So let's just go ahead and just demo that capability really quickly. If I come into Cubit, the Python script, and do an import sys, and do sys.version, you can see that this version of Cubit was packaged with Python 3.10.5. Now, if I come in here and copy this little script, Python script, and bring up a window and start up Python. My version of Python here is 3.7.9. Previously, this would not have worked. But now if I go ahead and paste that little script in here, we go through, we do some initialization, it does the Cubit startup, and I can issue Cubit commands from this level. And if I do just something simple like with volume one exists. So that works. That may seem like kind of a little thing, but for many of our users that are doing scripting, this is a big deal. So that's a nice new feature, new capability. Another thing to do with Python is we've standardized the use of the underscore name value. Standard Python defines this underscore name as being main. Now, if you are inside of Coreform Cubit, once again, I'm back here in the Python script. If I check this value of name, it is now Coreform Coreform Cubit . That means that if I have a script that I'm starting up and I have something like, hey, if name is main or name is Coreform Cubit, I can run my script either place from inside Cubit or just from the command line and do testing and do validation that way. Once again, that's a little thing seemingly, but it's a nice thing in terms of usability for script users. One of the other big changes in this version is we've upgraded the version of ACIS. We've upgraded to the latest version, which is ACIS 2023.1. Part of the reason for doing that is we get support for new CAD system imports. As an additional paid option, you can also get importers that support CATIA, NX, Parasolid, Creo, or SolidWorks, and do direct import from those formats right into Cubit. And since many companies tend to upgrade their CAD systems fairly regularly, this now supports the latest versions from this year as well. There's also been some improved stability. ACIS improved some of the error messages. We also fixed some of the regressions. So one of the things we noticed with the previous version is in this model on the left, there's some composite surfaces and the parameterization of those surfaces was just wrong. So I didn't get a decent mesh because the surface parameterization was wrong. With this latest version, with those composite surfaces in this particular case, the surface parameterizations have been corrected, and I now get a good tri-mesh. The case here on the right is something that just stopped working. Let's go ahead and take a look at that example. This is the tweak journal. Let's just go ahead and set it up here. Okay, so the idea here is what I want to do is I want to take this surface and project it down so it matches exactly with these sets of surfaces. So if I come into surface, modify, tweak, and I'm going to target surfaces. This is my source surface. And my target surface, I want to pick this one. And if you haven't seen this, there are several options that you may see on the pop-up menu. For example, there's the select continuous. And rather than having to do a pick individually of all those surfaces, I can do a select continuous and just get all of those in one operation. And if I hit an apply, or once again, I can always do an Alt-A instead of having to go over and hit that button. I tweak that source surface down to those target surfaces. So that is something that was failing. It's now working. I was happy as I was going through doing testing to see, oh, that's a regression that was fixed. One of the things that we typically see is that as we change ACIS versions, fixed IDs may change. So that can be an issue if you have journal files that you've created in the previous version of Cubit that you are reusing, or perhaps that are important things that you want to archive. One of the things to do is before upgrading to this latest version, you make an ID-less version of this. Let's take a look at a sample ID-less journal file. So this is an ID-less journal file for this particular model. And what it does, it goes through and does web cuts. It adds some splits along these composites around the bevel, the blends, and then does composites to improve the mesh quality. So there's a lot of picking of vertices, a lot of work that goes into modifying this model to make it all hex meshable. And instead of doing things like select a given surface, let me just go ahead. We have this form that we call an ID-less journal file. And I can do, let's just come to the command and say, highlight that given surface. So the first operation goes through and removes all of the chamfers around those holes. So instead of saying surface 12, I can use this ID-less format to do that. Now, how do I create my own ID-less journal file? Actually, let's go ahead and, just for fun, before I do that, let's go back here and we're just going to run through this. Okay, so there's the operations done completely without any fixed IDs. So let's do another one. Let's say I want to now create an ID-less journal file of that previous example we were looking at. So up here on the toolbar, there's this play ID-less journal file. What I do is I select a journal file that I want to convert, open that journal file. Once again, typically do this in a version of Cubit that you know that the journal file IDs work. And I'm going to convert from absolute IDs to relative IDs. I'm going to record this to a file. And I've done this before in practice. So I'm just going to overwrite this. And hit finish. It goes through, plays that journal file. But now, if we open up that file that we just created, where before I had IDs, so for example, what were my source and target surfaces, or what were my volumes that I modified? You can see now I have this ID-less format. And that works as an archival method through multiple versions of Cubit. So far, it hasn't failed for us. It's looking very stable. So that's just a tool in your arsenal. If you are using scripts and you want to make sure that they will continue to work through different versions of Cubit as we modify ACIS versions. Let's just talk quickly about some of the bug fixes. I think this is probably the major bug fix that we did, is speeding up auto size. One of the things that we found as we were testing problems with auto size, we found that certain kinds of geometries took a long time to calculate the surface area. This little triangular surface is a degenerate spline surface. And in just calculating the area of this one thing, took nearly 5 seconds. We've modified the algorithm for calculating the area and doing auto size on this so that instead of 5 seconds on this one surface, it now takes 1/100th of a second. So if you have models that have complex blends in them and they're taking a long time to auto size to the point where some of our users were just saying, just don't even do this operation, Control C, go do something else, and coming back. Those should be much faster for those kinds of models. In general, I have a number of different things that I've taken. And in this case, where I had 18 solids and 45,000 different surfaces, there were very few to maybe even none of these kinds of surfaces. We still get a little bit of improvement. In this case, with 5 sheet bodies, there were some surfaces that were causing some degradation. So it really depends on the model and what you have, but overall, we should see improvement in how long it takes to auto size a model. If you get that progress bar that's just crawling as you're doing auto size when you try to do something, we're hoping this should make a big difference. Some new and improved capabilities. For LS-Dyna, we now support exporting pyramid elements. So that's a new element type that we have not supported. We had a user request for that. That's supported. We also now support importing LS-Dyna files. Previously, if you had a mesh model in LS-Dyna format, you could not bring that into Cubit, Coreform Cubit. You can do that now. I'd recommend looking at the release notes to see what exact cards are supported. All of the basic element and node cards, of course, are supported, but formats like the different complex materials and those kinds of things are not imported. Let me go through and show one other feature. We're going to go ahead and finish up fairly quickly today. Hopefully we'll have some time for questions and answers on this webcut offset capability that we introduced last release. It's now handles additional cases. It's a little more robust. There are still going to be cases that I'm sure you'll find issues. If you find issues when you need to use this, please let me know. Let's go ahead and look at this example. Oops. I must have killed my window. Okay, we'll bring up this webcut offset, bring in our model, and so what this does is it actually takes all of these surfaces, take my original piston model, takes the surfaces, offsets into the model, the specified distance, and creates a geometric boundary layer on this model. These sheets are all hex meshable because they're just swept from inside to outside. They form this, like I said, this nice little geometric boundary layer on a fairly complex model here. Now, one of the things that we will continue to work on is those simple models should just all automatically hex mesh. Some of them, the auto hex mesher doesn't recognize. So I can put a hex mesh on all of those things. You'll notice here that I've got angled sections around each of those. And now based on this model, I can go ahead and mesh the interior with a tap mesh, and it will create pyramid elements on the interface between the hexahedra and the tetrahedral elements. A couple of things to watch out for when using this capability. The mesh sizes need to be small enough that you can insert pyramids in small sections. And the offsets also need to be small enough that they can actually insert in. So those are a couple things to watch for. These are designed for doing boundary layers. Typically, those would be fairly small anyway. Just for fun, we've got a little bit of time. Let me show you something else that I was playing with just as a mesh volume refine. And I'm going to do a mesh sheet refine on an edge. So with the mesh size that I gave it, it put in 2 elements. Let's say I want to put in another finer layer on this edge close to the model. Now let's do it on the outside. Okay, so I'm just going to select that edge, and I'm going to put in 2 intervals. I hit apply, and it goes through. Because this forms a continuous boundary layer all through there, I split this edge, and you'll notice that up here at the top, it's split it as well. So I can refine those boundary layers once I've put them in and do some operations that are pretty nice. Okay, I said this was going to be kind of a short webinar starting out. I think we are there. I see that we have one Q&A. Jessica, you want to go ahead and ask that question?
So in 3D, is there an option to create boundary layer under a specific surface?
A boundary layer under a specific surface. So the boundary layer capability in Cubit allows you to specify a surface on a volume. The boundary layers capability in Cubit is maybe not as robust as I would like, but we can do something like, I'm going off script here, so let's just take a very simple brick and we'll specify a mesh boundary layer and create that boundary layer given this, let's say on this top surface on that volume, add. And the settings for this, oh, let's say that we'll go with a 0.05. So there's a boundary layer on that top surface. And if I go ahead and mesh volume 1, okay. Created the boundary layer on that top surface, but it did not mesh. I told you I'm going off script and I don't have a lot of faith or confidence in some of this boundary layer stuff. Okay, that is why did that not say? All right, let's do this. Let's go ahead and make it explicitly a sweep going from top surface to bottom surface. Nope. Huh. How about we do it sweeping this way? There we go. Okay, got it. I understand why. So because this surface, this top surface inside the boundary layer is a map, but these surfaces, it didn't recognize as a map. So there's a case where I have a boundary layer. I can turn off the visualization of that boundary layer with that little tab right there. I can use the boundary layer to create a single version. Now let's also try this. Once again, I'm off script, so let's just reset. Let's do the same thing, only now we're going to go ahead and use this webcut offset tool. And I'm going to go ahead and say here, and let's do an offset of nope. That was a brick X1. Okay, so there I just created a geometric offset in a simple volume like this. You know, you could webcut, you could do anything, but that just creates that same kind of condition there. And those are merged together. A surface width is merged. Yes. So you can use that webcut offset tool to create a geometric boundary layer as well. Okay, any other questions?
Nope, I think we're good. If anyone has any other questions, please post to our forum and we're happy to answer those questions there, especially if you're watching the recording. Well, thank you, Karl. This was fantastic. I think I learned a lot, so thank you so much. And thank you everybody for attending. And we will send this out as soon as I get it uploaded to everybody who's registered.
Thank you very much for your time.